Nanoparticles are fascinating for art, images, and canvases because they offer unique properties that significantly enhance artistic expression. They manipulate light to produce vibrant and unique colors, much like tiny pieces of a puzzle creating different pictures, depending on their arrangement. Nanoparticles also enhance the durability and stability of paints, making artworks last longer without fading, similar to how high-quality, weather-resistant paint keeps a house looking fresh. They can create special effects like iridescence, akin to the shifting colors of a soap bubble, adding dynamic elements to art. For example, quantum dots are nanoparticles that emit light in various colors when exposed to UV light, allowing artists to create pieces that glow in vibrant hues under specific lighting conditions. Plasmonic nanoparticles, such as gold and silver, produce brilliant colors due to their ability to resonate with light at specific wavelengths, resulting in dynamic and eye-catching effects in artworks. Additionally, dark nanomaterials like carbon nanotubes can absorb nearly all light, creating an ultra-black appearance that adds striking contrast and depth to art. Used in paints and pigments, nanoparticles achieve more vivid and varied colors, such as quantum dots that make pieces glow under certain lighting. On canvases, they create textures and finishes like metallic sheens or matte surfaces, providing unique visual qualities. In restoration, nanoparticles clean and protect artworks without damaging the original material, preserving historical pieces. For instance, silica nanoparticles can be used to reinforce and protect frescoes, ensuring they remain intact for future generations. Essentially, nanoparticles are like magic sand changing colors, invisible armor protecting art, and chameleon particles altering paint properties to expand creative possibilities. Nanoparticles are currently being used in art today by various artists and researchers who are exploring their unique properties to create innovative and captivating artworks. Here are some notable examples. The use of quantum dots. Quantum dots have been incorporated into artworks to create pieces that glow under specific lighting conditions. For instance, the artist and scientist duo Nanotronics have used quantum dots in their art installations to produce vibrant luminescent displays that change color based on light exposure. Plasmonic nanoparticles in paints. Artists have experimented with plasmonic nanoparticles, such as gold and silver, to achieve vibrant and dynamic colors that shift with viewing angles. The luminous Earth grid by artist Stuart Williams is an example where the interplay of light and plasmonic nanoparticles creates a shimmering effect that transforms with the observer's movement. Ultra-black materials. Vantablack, a material made of vertically aligned carbon nanotube arrays, absorbs 99.965% of visible light and has been used by artists to create visually striking pieces. Anish Kapoor, a renowned artist, has famously used Vantablack to create sculptures and installations that appear almost two-dimensional due to their profound blackness. Restoration and conservation. In the field of art conservation, nanoparticles are being used to restore and preserve historical artworks. For example, calcium hydroxide nanoparticles have been employed to stabilize and consolidate deteriorating frescoes, ensuring their longevity while maintaining their original appearance. Modern art installations. Contemporary artists are also integrating nanoparticles into their installations to push the boundaries of visual art. The nano art movement, pioneered by artists like Chris Orfescu, involves creating artworks that incorporate nanoscale structures and materials, often visualized through advanced imaging techniques. These examples highlight how nanoparticles are not just theoretical tools, but are actively being used to enhance and transform the field of art, opening new avenues for creativity and expression. The applications of nanoparticles extend far beyond the realm of art, touching upon various fields such as medicine, electronics, and environmental science. In medicine, nanoparticles are being explored for targeted drug delivery, enabling more precise treatment with fewer side effects. The electronics industry leverages nanoparticles to create faster and more efficient computer chips and displays. However, it is in the world of art where nanoparticles truly shine, adding a new dimension to artistic expression. From ancient times to the present day, artists have harnessed the power of nanoparticles to create stunning visual effects. Join us as we delve deeper into the fascinating intersection of art and nanotechnology. To comprehend the captivating colors produced by nanoparticles, we must first understand the nature of light itself. Light, in its purest form, encompasses a spectrum of colors, each associated with a specific wavelength. When light interacts with matter, it can be absorbed, reflected, or scattered, and it's this interplay that gives rise to the colors we perceive. Imagine light as a wave, carrying energy as it travels through space. When this wave encounters a nanoparticle, it sets the electrons within the particle into motion. The way these electrons oscillate and interact with the incoming light determines which wavelengths are absorbed and which are reflected back to our eyes. The size, shape, and composition of a nanoparticle dictate its interaction with light. For instance, a nanoparticle smaller than the wavelength of visible light will primarily scatter light, giving rise to brilliant hues.
One of the most intriguing phenomena responsible for the vibrant colors produced by nanoparticles is surface plasmon resonance, or SPR. In metallic nanoparticles, such as those made of gold or silver, the outermost electrons form a collective sea of electrons that can move freely across the particle's surface. When light interacts with these free electrons, it can induce a collective oscillation known as a surface plasmon. The frequency at which these plasmons resonate is highly dependent on the size, shape, and composition of the nanoparticle, as well as the surrounding medium. As the plasmons resonate, they absorb energy from specific wavelengths of light. The remaining wavelengths are then scattered, giving the nanoparticle a distinct color. This phenomenon is responsible for the brilliant colors observed in stained glass windows, where metallic nanoparticles embedded in the glass selectively absorb and scatter light.
Nature, a master artist, has long harnessed the power of nanoparticles to create some of its most stunning visual displays. From the iridescent wings of butterflies to the vibrant feathers of peacocks, nanoparticles play a crucial role in producing these captivating colors. The wings of many butterfly species contain intricate structures made of chitin, a naturally occurring polymer. These structures are arranged in a periodic lattice, much like a photonic crystal, and interact with light in a way that produces vibrant iridescent colors. The precise colors observed depend on the spacing and arrangement of the chitin nanostructures, which vary between species. Similarly, the brilliant colors of peacock feathers arise from the interaction of light with melanin nanoparticles arranged in complex layered structures. The spacing and arrangement of these nanoparticles determine which wavelengths of light are reflected and absorbed, giving rise to the peacock's dazzling display of colors.
Our journey begins with the Lycurgus cup, a testament to Roman artisans' ingenuity. This glass chalice appears jade green in reflected light, but turns ruby red when lit from within. In the 1990s, electron microscopes revealed its secret. Tiny gold and silver nanoparticles, 50 to 70 nanometers wide, create this effect. Fast forward to the Middle Ages, a period renowned for its magnificent cathedrals adorned with breathtaking stained glass windows. These vibrant masterpieces owe their brilliance to the skillful use of nanoparticles, albeit unknowingly by the artisans of the time. Medieval glassmakers, through a process of trial and error, discovered that adding metallic compounds to molten glass produced striking colors. Gold chloride, for example, yielded a deep ruby red, while silver nitrate produced a warm yellow. Unbeknownst to them, these metallic compounds were forming nanoparticles within the glass matrix, giving rise to the vibrant hues. The color of stained glass arises from the interaction of light with these metallic nanoparticles. When light passes through the glass, the nanoparticles absorb certain wavelengths while allowing others to pass through.
During the Renaissance, a period marked by artistic innovation and a renewed interest in classical art forms, a technique known as Lusterware gained prominence in ceramics. Lusterware, characterized by its iridescent metallic sheen, was highly sought after for its decorative appeal and luxurious appearance. To achieve this lustrous effect, ceramic artists developed a sophisticated process involving the application of metallic oxides, such as those of silver and copper, to the surface of glazed pottery. These metallic oxides, when fired at high temperatures in a reducing atmosphere, transform into nanoparticles dispersed within the glaze. The iridescent sheen of lusterware results from the interaction of light with these metallic nanoparticles. When light strikes the surface, it is both reflected from the glaze and scattered by the nanoparticles within. This interplay of reflection and scattering creates the characteristic metallic luster and iridescent effects, adding a touch of opulence to the ceramic pieces.
Nanoparticles in art bridge scientific innovation and artistic vision, expanding creative possibilities. Artists use nanotechnology to push artistic boundaries and challenge perceptions. Nanoparticle-infused paints offer unprecedented control over color, texture, and light. Imagine paint changing color with light or ink shimmering with iridescent hues.
Vantablack, the embrace of the void. Vantablack absorbs almost all light, creating a bottomless void illusion. Developed by Surrey Nanosystems, it's made of carbon nanotubes. Light gets trapped and absorbed within these nanotubes. Vantablack is the blackest substance, absorbing 99.965% of visible light. Anish Kapoor holds exclusive artistic rights to Vantablack. This sparked debate on color ownership and artistic exclusivity.
Quantum dots, painting with light itself. Quantum dots are semiconductor nanocrystals that emit light of specific wavelengths. They offer artists a new palette of vibrant, highly saturated colors. The color emitted is determined by their size and composition. This tunability makes them versatile for artistic applications. Section 1. The Artist's Nano Palette. Materials for Nanoparticle Art. The realm of nanoparticle art offers a diverse palette of materials, each with its unique characteristics and potential for artistic expression. From metallic inks that shimmer with iridescent hues to nanoparticle-infused paints that defy conventional color boundaries, artists now have access to a world of creative possibilities previously unimaginable. One of the most accessible entry points for artists venturing into the world of nanoparticles is through commercially available metallic inks. These inks, typically containing nanoparticles of gold, silver, or copper, offer a range of brilliant reflective colors that can add a touch of opulence and intrigue to any artwork. These inks can be applied using traditional painting or printing techniques, allowing artists to seamlessly integrate them into their existing workflows. For those seeking a more immersive experience with nanoparticles, nanoparticle-infused paints offer a wider spectrum of colors and effects.
Section 2. Safety First. Handling nanoparticles with care. While the artistic potential of nanoparticles is vast and inspiring, it's crucial to approach this exciting medium with a mindful awareness of safety. Nanoparticles, due to their incredibly small size, can pose potential health risks if not handled responsibly. However, with proper precautions and a commitment to safe practices, artists can confidently explore the world of nanoparticles while minimizing any potential hazards. The primary concern with nanoparticles lies in their potential for inhalation. When inhaled, these tiny particles can penetrate deep into the lungs and potentially enter the bloodstream, leading to respiratory issues or other health complications. Therefore, it's essential to work in a well-ventilated area, ideally equipped with a fume hood or respirator mask specifically designed for nanoparticle filtration.
Incorporating nanoparticles into artworks. Integrating nanoparticles into artworks requires artistic vision and technical understanding. Techniques vary based on nanoparticles, desired effects, and personal style. Mixing nanoparticles with traditional materials is versatile. Metallic nanoparticles create shimmering iridescent effects. Experimentation yields unique results. Nanoparticle solutions can be applied using brushes, airbrushes, or inkjet printers. This is ideal for intricate patterns and three-dimensional effects. Nanoparticles in polymer composites create light interactive sculptures.
Envisioning nanoparticle art's future. The future shimmers with possibilities as limitless as the infinitesimal particles themselves. Imagine canvases pulsating with life, colors shifting and morphing in response to their environment. This is the future of nanoparticle art, where art, science, and technology blur into a breathtaking tapestry. Smart art materials transcend traditional pigments, creating dynamic, responsive artworks. Imagine paints that change color with temperature, reflecting the viewer's emotions, transforming static paintings into living, breathing artworks with ever-evolving patterns. The possibilities are as boundless as the nanoscale world itself.
art that breathes and responds. The future of nanoparticle art encompasses interactive, responsive artworks that engage the viewer on a deeper level. Imagine stepping into an art installation where the walls breathe, responding to your presence. Nanoparticles offer a unique platform for creating interactive artistic experiences. Sculptures that shimmer and change color as viewers approach, or paintings that react to the viewer's gaze, their colors shifting and swirling. Digital technology amplifies the potential for interactivity in nanoparticle art.
Beyond the horizon, the uncharted territory of nanoart. Venturing into nanoparticle art, we redefine the very essence of art. The nanoscale world offers artists control, blurring real and imagined. Artists and nanotechnologists push scientific and artistic boundaries. Imagine sculptures from self-assembling nanostructures, or paintings with atomic precision and vibrant colors. The ethical implications are as profound as the aesthetic. We must grapple with authenticity and ownership. Is a nanosculpture less art than marble? Can an algorithm creating nanoscale patterns be an artist? These questions shape the future of nanoparticle art. Embracing the potential of nanoparticles. Nanoparticles have transformed the artistic landscape, ushering in a new era of creative expression. These particles empower artists to transcend traditional media, unlocking colors, textures, and light interactions. From the Lycurgus cup to Vantablack, nanoparticles in art showcase human ingenuity and creativity. Medieval stained glass, Renaissance lusterware, and today's installations highlight their transformative power. The story of nanoparticles in art is far from over. As we deepen our understanding, we marvel at the artistic wonders that await us. The future canvas invites artists to explore where science and art coalesce into creativity. The fusion of art and science, a catalyst for creativity and innovation. The convergence of art and nanotechnology ignites innovation and pushes the boundaries of human expression. Scientific inquiry intertwines with artistic vision, challenging our perceptions and expanding our understanding. Artists bring a fresh perspective to nanotechnology, using nanoparticles as pigments on a limitless palette. Their creative explorations inspire scientists to envision new possibilities for nanomaterials. This symbiotic relationship is evident in collaborative nanotechnology projects. A call to exploration, unveiling the unseen, igniting the imagination. A new era in art and nanotechnology beckons artists to delve into the unseen, embrace the transformative power of nanoparticles, explore their unique properties, and push the boundaries of art. Let your creativity guide you into this uncharted territory.